Okay, so in this video, I'm going to be discussing what an independent variable is and what a dependent variable is, and how do levels play into that. And you might be thinking, well, I already know what that is. That's been covered, over and over and over again. I transferred here. I already did this class. Well, you know what? Humor me, but then also at the same time, keep in mind that this is very important to understand when coming up with a hypothesis for a main effect and interaction, right? So you want to make sure you have this fundamental down. Now, one thing I do want to establish from now until the end of the course is the use of IV and DV. So from now on, anytime I say IV, I'm referring to an independent variable. Anytime I say DV, I'm referring to a dependent variable. So keep that in mind. IV, independent variable. DV, dependent variable. Okay, so let me go ahead and draw this out. So let's say my IV is caffeine. Okay, so if my IV is caffeine, and I've let you know that, that's all you know. You know that the IV is caffeine, that's what it's called. You don't know what the comparison groups are or what the levels are of that IV. You can guess, right, based on your previous classes. Maybe you're thinking, oh, well, you have to have an experimental group and you have to have a placebo group, or you have to have comparison groups. So that's what I'm going to ask you all to start switching towards thinking. Well, okay, you know that most likely you're going to have a comparison group. You might have a placebo group and you might have an experimental group, but at the very least when dealing with experiments, and the way we're going to be talking about studies is mostly in terms of experiments, you need to have comparison groups, right? So in caffeine, well, what are the comparison groups? What are the different levels I'm comparing? Let's say I told you, okay, well, I'm comparing 1 cup of coffee, that was an E, and no coffee, which might be decaf, right? So 1 versus 0. Now, decaf does have some caffeine, so it's not technically correct, but hopefully you see what I mean, right? We're comparing people who get about 95 milligrams of caffeine, I think that's what's in a normal cup of coffee, to a very minuscule amount that's present in decaf, a decaf cup. How do people, well, actually, what are we comparing them on, right? So we know we're comparing people who got like 1 cup of coffee and people who got decaf, but based on what are we comparing them? So then that's where you're looking for the DV. Well, okay, fine, I know what you're comparing, but what's the measure you're comparing them on, right? What are you looking at? So in this case, let's say I'm looking at attention. Attention in class. So I'm looking at attention. You might have questions like, well, how are you measuring attention? We're not going there yet. But we know that the DV is attention, right? So far we know we have the decaf group, and we have, actually, there's a decaf group, and we have the caffeine group, and we're comparing them to see, let's see if this works. Oh, there you go. How attentive students are across those situations, right? The students that got a cup of coffee versus the students who got decaf coffee, how attentive are they, right, in comparison? Now, when I share this example, students start sharing things like, well, there's all these confounds. You haven't taken into account how much coffee they take and how used to they are to drinking caffeine. And yeah, that's true. But I'm simplifying it here. Right now, we're just thinking about it in terms of one group compared to the other group. Now, let me change colors. Okay, so in this example, okay, this is a DV. right? And here's the IV. Where are the levels? The levels are the different groups that form the IV. Caffeine, no caffeine. Or cup of coffee, decaf, right? Those are the two levels of my caffeine IV. That's how I defined it. Because let me just show you. Let me create a new page. There you go. Maybe my IV, that's supposed to be a V, is 1 cup, 2 cups, water. Now you might have issues with this, right? You might say, well, the people that have water, they're going to know they have water, so you're not going to see, you know, they might act less attentive because they know they only had water, right? So that might bias the data in some way. Fine, good critique, but it doesn't matter. These are still the levels of my IV. 1 cup of coffee, 2 cups of coffee, water. Some people get 1 cup, some people get 2 cups, some people get just a cup of water, right? These are the levels of my IV, and my DV might still be attention. Now let me take it a step further. In your studies, you're going to have this kind of setup where you might have, let's say, male, female, and I'm just going to use my favorite IV, caffeine, no caffeine. So you might have this kind of setup, and you might be thinking, well, okay, cool. Where do you go from here? Well, the reason why I'm bringing this up is because you're going to have each, in your studies, you're going to have 2 IVs like I have here. And I want you to make some hypotheses regarding the main effects. The main effects are, just looking at one IV, actually let me go back. Is there a difference between these participants and these participants? That's the main effect. Looking at one IV, do we have a significant difference between these two groups? Here, I have 2 IVs, IV 1, IV 2. And there's no particular way I labeled them. The top one could have been IV 1, but I just labeled it that way. I'm only explaining that because I remember as an undergrad thinking, well, how do you figure out which one's IV 1 and which one's IV 2? It doesn't matter. The point is that you know there's 2 IVs, right? When I ask you, is there a main effect for the caffeine independent variable? What I'm asking you is, just looking at caffeine and no caffeine, is there a significant difference between the two? When I ask you, is there a main effect for gender, or actually sex of the participants? I'm asking you, is there a significant difference between male and female participants in terms of their attention, right? Here too, for caffeine, I'm asking you for the main effect. Is there a significant difference between the caffeine and no caffeine group in terms of their attention, right? We have to bring that DV back in, right? So when I'm asking you to give me a hypothesis for the main effect, I'm asking you, just looking at one of your IVs, you might have participant sex, you might have age, right? Younger, older, you might have ethnicity. I'm asking you, based on those 2 levels, because the IVs I've given you only have 2 levels, what do you expect that difference to look like? So in other terms, do you expect, let me change color again. Do you expect male participants to be more attentive than female participants, or vice versa? Do you expect caffeine, participants who received caffeine, do you expect them to be more attentive than the no caffeine group, right? So I'm asking you, make a prediction. What do you hypothesize? Do you expect, just based on that one IV, not both, ignore one, look at one, based on your levels, what do you expect them to be like? What do you expect the pattern to look like in terms of the DV? Okay. Now, final thing, interaction. So an interaction, so I am asking you to do a hypothesis for the interaction, but here's the thing. You're taking into account both IVs now. So let me draw this out. So in terms of, let's see, so gender, okay, give me a second. There you go. So in terms of gender and caffeine, how do they affect attention? That's supposed to be I. So how do they both together impact attention, right? How do they interact to influence the attention you're seeing in the study? I use the X because oftentimes you'll use that as a reference to interaction. Sometimes you'll see a star in stats output, but that's what I'm asking. So how do you imagine both IVs will factor into influencing the DV? In the instructions for that hypothesis activity, the proposal activity, I give you some instructions on how to set that up. But one thing you could say is, well, I expect male participants who receive caffeine to be the most attentive. You know, I'm not sure why you would expect that, but that would be a hypothesis that would take into account both gender and caffeine, both of my IVs. So again, reminder, main effect, you're looking, or main effect hypothesis, you're making a prediction for one IV and thinking about, well, will there be a difference, and what will that difference look like? Will men be higher in attention than women, or women higher than men? Make some prediction. For caffeine, I would expect the caffeine participants to be more attentive than the non-caffeine participants. So that would be my hypothesis for the main effect of caffeine. Okay, so hopefully this is helpful. If you have questions, reach out.